an ice cream cone on a scoop, a capsule, a circus tent. They're all just simple solids stuck together. A cone, a cylinder, a hemisphere, and this chapter is about measuring two things for them: the surface you can paint and the volume they hold. The twist is that those two behave by opposite rules, and once you know the rules, every problem is just plugging in formulas. Let's go. Start with surface area and one key insight. When you join two solids, the faces where they touch end up inside the new shape, hidden. You can't see them or paint them. So the surface area of a combination is only the sum of the exposed surfaces, usually the curved ones. That's why a combined solid surface area is always less than the two full surface areas added up. You need 6 basic surface formulas at your fingertips. Cylinder curved surface, 2πrh. Cone curved surface, πrl, where L is the slant height. Hemisphere curved surface, 2πr². Full sphere, 4πr². Cube total surface, 6aa². Cuboid, 2 times lb plus bh plus hl. Memorize these. Everything builds on them. One formula trips people constantly. The cone uses its slant height L in πarl, not the vertical height. If you're given the vertical height h, first get the slant height from Pythagoras. L equals the square root of r² plus h². Find L before you touch the cone's curved surface formula. Two classic shapes. A toy, a cone sitting on a hemisphere of the same radius. Its surface is the cone's curved surface plus the hemisphere's curved surface, PERL plus 2PR². The two flat circles are joined and hidden. A capsule, a cylinder with a hemisphere on each end, 2πrh plus 2 times 2πr² for the two domes. Sometimes a flat face stays partly visible, so you adjust. A hemisphere sitting on top of a cube. Take the cube's total surface, subtract the circle it covers, then add the hemisphere's curved surface, 6a² minus πr² plus 2πr², which tidies to 6a² plus πr². And for a hemispherical cavity scooped into a face, it's the same logic. Subtract the flat circle removed, add the inner curved surface. Quick worked one. A cube of edge 5 has a hemisphere of diameter 4.2 on top, with pi as 22/7. The radius is 2.1. Surface is 6a² plus πr², 6 times 25 plus 22/7 times 2.1 squared. That's 150 plus 13.86, equal to 163.86 square centimeters. So, surface area means carefully tracking what's hidden and what's exposed. Volume is the friendly opposite, and the rule is much simpler. When you join solids, their volume simply AD. Nothing is lost in joining, so the volume of A joined to B is just the volume of A plus the volume of B. No subtracting hidden faces, no adjustments. You sum the pieces, full stop. That's the whole principle. The 6 volume formulas: cuboid LBH, cube A cubed, cylinder pi r²h, cone 1/3 pi r²h, sphere 4/3 pi r cubed, hemisphere 2/3 pi r cubed. And the one exception to volumes add: if a cavity is scooped out, say a hemispherical dent in the bottom of a glass, the actual capacity is the container volume minus the cavity volume. Worked example: a toy, a hemisphere of radius 2 with a cone of radius 2 and height 2 on top, pi as 3.14. Volumes add 2/3 pi r cubed plus 1/3 pi r² h. That's 2/3 times 3.14 times 8 plus 1/3 times 3.14 times 4 times 2. 16.75 plus 8.37, which is 25.12 cubic centimeters. And a cavity example. A cylindrical glass, radius 2.5, height 10, with a hemispherical bump pushed up at the bottom. The apparent volume is PIR²h, 3.14 times 2.5 squared times 10, equal to 196.25. The bump removes 2/3 pi r cubed, about 32.71. So the actual capacity is 196.25 minus 32.71, 163.54 cubic centimeters. Hold the contrast in your head because that's the whole chapter. Surface area, only the exposed surfaces. Hidden faces vanish, so you sometimes subtract. Volume, everything adds, and you only subtract when something is genuinely scooped out. Same solids, two opposite bookkeeping rules. Your turn, the question's on screen. Pause if you like, but try it first. 10 seconds, go. Two hemispheres of the same radius together make one full sphere, so the volume is 4/3 πr cubed, with r equal to 3. That's 4/3 times pi times 27, which is 36 pi cubic centimeters. Option B. Lock it in. Surface area of a combination is the sum of the exposed curved surfaces. Hidden joins don't count, and a cone needs its slant height. Volumes simply add, and you subtract only a scooped cavity. Last challenge. It's on the screen. Don't say it aloud. Type your answer in the comments, and I'll pin the right one. And that's surface areas and volumes. Combine the basic solids, track exposed surfaces, add the volumes. Free notes with 60 practice questions are in the description. Subscribe for the next chapter. This is Clarix. Keep going.